Okay, so this is a quick explanation of what we mean by average value of a function. We will revisit this idea once we've talked about what the definite integral is. So we want the average value of the function f of x on the interval from a to b. So if we took an average of, let's say, the quizzes that you take in this course, you would add up all the quizzes and you would divide by the total number of quizzes. So we're going to kind of do something like that. I'm going to split this up into n subintervals. And I don't know what n is right now, but basically we're going to take a function value in each interval, add all of those up, and divide by n. That will be the average value. So we're going to do n subintervals, and for the cases of this explanation, I'm going to use a right endpoint to, well, actually, I'm not going to talk about that yet. All right, n subintervals. Now I'm going to take, in each subinterval, I'm going to take function value. There's one. So I'm sampling one function value in each subinterval. And I'm going to add all of those up, all of these function values up. So that we get the following. We're going to get, okay, the first one, maybe that's f of x sub 1. The second one, f of x sub 2. We picked one in each subinterval, so we have n of these guys, n function values, and we're going to divide that by n. Great. Now, that should give us the average of this function on the interval from a to b. We know also, so this is average value. Average, that's what this means. But we also know that the width of each subinterval, when we divide into n pieces, is equal to b minus a divided by n. This is the same thing as saying that n is b minus a divided by delta x. So I'm going to rewrite this average value, and I'm going to talk about why this actually is not exact. We'll talk about that in a little bit. I'm going to rewrite it so I have f of x sub 1 plus f of x sub 2 all the way to however many intervals I'm using, in this case n of them. And I'm going to replace n with b minus a divided by delta x. Now, doing that is the same thing. Since I'm dividing by a fraction, that's the same thing as writing f of x1 plus f of x2 all the way to f of xn times the reciprocal of the denominator, delta x over b minus a. That's the same thing. Notice what we have in the numerator. In the numerator, we have a Riemann sum. So this is, we can rewrite this as 1 over b minus a times f of x1 delta x plus f of x2 delta x, and so on. What's inside of the bracket, that is a Riemann sum. And in class, we learned different ways of coming up with this Riemann sum. We could use the right endpoint, the left endpoint, we could use an upper sum, lower sum, or midpoint. And then all we have to do is divide by the length of the interval, 1 over b minus a. And that gives us an approximation of the average value. The reason it's not exact is that we took one value from each subinterval. We didn't take all of the possible values and averaged all of them. We only took one of them. So this cannot be exact. So just to give you an example of how this would be applied, imagine that the function that we're dealing with is a temperature function. And that temperature, maybe we're looking at it over the month of, let's say, from day 1 to day 31 in August. Well, clearly this is not what happened in August. It didn't start low and went very high. Not here anyway. But we're basically saying split it up into maybe every other day or every 3 days or whatever, and then pick a temperature during some time in that interval. Well, that's not going to give us a good average, right? Because during the day, the temperature ranges from maybe from 65 to 90. And if I take 65, I'm going to get a very different average for that. If I take 65 for that day, I'm going to get a very different average than if I take the 90-degree temperature, maybe that happened at 2 p.m. So this is still just an estimate of average value when we're dealing with Riemann sums. We will revisit average value when we've defined the exact area under the curve, because then we'll be able to talk exactly about what average value is. But I wanted to give you this video because I think this might help you in one of the problems in our homework. All right, see you on Friday.